Hello, my name is Quidmel, and I'm here to go over my research project for spring semester 2015 in my Human and Machine Intelligence course. And I had the opportunity to review several papers on IDS systems, and I thought it was a good focus point for my research project. And the objective I'm looking to do is look into IDS system detection improvement using machine learning and system identification approaches. Let's go here. Okay, so for I want to talk about IDS systems and issues regarding them, solutions using machine learning based, which I covered one paper in a previous class period, another paper I want to cover in this presentation, use identification as well, and how it formed literature methodology, as far as what data sets I'm going to use for my self-supervised learning, and data preprocessing, we finish up with our evaluation metrics regarding this semester project. As far as choosing detection systems, what are they? They essentially monitor network activities for malicious activities and policy violations. They focus on incidents regarding the users and logging that data and reporting toward officials so they can resolve what's going on. The problem with IDS systems is that they have a big issue with false alerts. Researchers, as far as analysts, have found that the amount of rules, as they increase them, the amount of false positives they have, as far as telling the user there's an issue that's actually present. But they also found that when they restrict the rules, they have less detection as far as the signature base, finding if there's a problem going on. So there's been several publications in machine learning, actually there's only two, let me correct myself, in machine learning to determine whether or not can we improve that using novel-based approaches, more precisely using semi-supervised learning techniques. So the first paper I want to talk about a little bit in general, and as far as basis, I'm using these papers as reference to building my project for semester. Somewhat basically wrote a paper on aiding intrusion analysis using machine learning based concepts. This was presented in 2013 at an international conference. And essentially they used SNIPS and machine learning to determine whether or not traffic involving users was interested or not regarding malicious activity. They compare and contrast semi-supervised learning techniques, and precisely I list the results on the right-hand side. And Table 2 essentially shows the results, giving a support vector machine with a PUK kernel and how well it performed. They show the accuracy regarding the whole data set, the RSC curve, precision, recall, and F measure. The accuracy is essentially showing your true positives plus your true negatives minus the whole data set. And regarding each class, 1 corresponding to was it interesting and 0 corresponding to if it's not interesting. They will then find the RSC, which is the balance between the true positive and the false positive, was about at both of them for the data set at 95%, well, roughly around 96%. And regarding the precision, which if we're considering all the data that was interesting, what fraction actually did have interesting characteristics, we found that predicting whether or not it's not interesting was at 95, but predicting whether or not it was interesting was at 85. And before I continue, they used a IT analyst to be able to determine whether or not it's interesting or not. Given the recall number of true positives number of true positives over the true positives and false negatives, it again did better for 0, which is not interesting, rather than predicting whether or not the number of positives, which is 1, at roughly around 8%. And F major was the balance between precision and recall, which essentially did better for 95% given 0 and 81% given 1. And this was supervised learning. For semi-supervised learning, looked at several approaches, one being low bound, using only 10% of the data set, and other bound using the whole data set, and they compare and contrast co-training against EM+, which stands for estimation maximization, and they found that co-training performed the best compared to all the other, compared to EM training, but using the upper bound had some cadences performing better than co-training. And given the last table, the mission in the paper, when you're comparing the baseline against supervised learning techniques and semi-supervised learning techniques, they found that the semi-supervised learning techniques did better than the baseline, but The supervised techniques perform better, only marginally, than the self-supervised techniques. And in the next paper, which I'm not going to go too much detail about, it involves Chan, which they was more of a case of showing the practicality of using the 2T1S, which is two teacher, one student algorithm, which is the multi-view algorithm. But they looking to use semi-supervised learning approaches for false alerts reduction, and this results giving supervised learning and semi-supervised learning, where we explored the different detection rates, giving semi-supervised learning and reduction rates, and looked at exploring semi-supervised learning detection rates and reduction rates. And overall, they found that it was a trade-off between detection and reduction rate, and supervised learning reduced alerts by 64.9%, and detection rate was basically around 74.6 true positive. For semi-supervised learning, the detection rate was around 85.1 true positive tests, and they reduced to 81.4% alerts. Regarding system identification, went too far. Regarding system identification, they found that I found in my research looking at IEEE and ASIM libraries, it's very limited involved ideas, which means it's non-existent. So I've yet to find any publications currently on using IDS systems, which gives us a good little gateway of trying to apply it to IDS system improvements using it. As far as methodology regarding my research project, I want to use a data set that's already provided, and I'm interested in using the DARPA, which was the one in 1999. If I find a more current data set, I want to use it for this project. But I've also seen some data sets on KDD Cup, which is a list of multiple machine learning approaches. And again, I mentioned those other options. DARPA data set contains TCP information, directory information on user, and we can process it through Snort or any other application to be able to determine how well it performs. As far as data processing, I'm interested in following Chan's system architecture. I felt that paper was very limited on the evaluation metrics, and I can see myself improving them. And I want to be able to look into labeling each feature space as non-alarm or non-alarm, again following more closely to Chen, and build features from the IDS system and use TCP connections. Now regarding temporal or time-based feature sets, I'm looking into using some cluster-based algorithm to essentially remove that time dependency, and I'm going to follow their architecture, which I showed an image of it on the. Let's see, I make that a little bigger. On the left bottom side, where essentially we look at the network information, we'll feed into Snort, and we do a network connection feature extractor, and we'll form that into our NFC instance database, and we'll feed that to our machine learning based algorithm engine. And I'm going to feed the same feature space to system identification to get to build models based upon that. And I know that this is not a SI or AE class, but user identification is essentially a way of building mathematical models based on time series, and I'm also considering using polynomial models regarding that. As far as evaluation, I am considering just exploring just different options and seeing how well perform. And evaluation of our performance will be done on looking at the accuracy, the sensitivity and recall, specificity, error, which is presented. Error is the number of false positives plus the number of false negatives over the whole data set. F1 score, which is a balance between the precision and recall, and RC curve, which again I mentioned before is number of true positive versus number of false positive rate. And that's basically it. If you have any questions, feel free to email me at quintonmail@myunt.edu or at quintonmail@yahoo.com, and it's QUENTINMAIL. Thank you very much for your time, and I hope everyone have a wonderful day.